All right, so moving on to the back side of our review. Number 5, a town has a current population of 36,500 and is increasing, let's circle that word increasing, at a rate of 1.5% per year. What will the population be in 5 years? All right, so anytime that we increase by a percent, that's an exponential growth situation. So we have a formula for exponential growth. F of x equals a times, a is our initial amount, 1 plus, because of the growth, r raised to the x power. And this r is our percent that we're growing by. We just have to write it as a decimal. And then x is our time in years. So what we're going to do is we're going to plug in our information and then grab our calculator. So we want to know what the population will be in 5 years. So we start with our A value, which is our initial amount, 36,500 times 1 plus. Now the R is the interest rate as a decimal. So 1.5%. You can move your decimal 2 spots to the left to turn a percent into a decimal, or you can take that and divide it by 100. Either way, you're going to get a 0.015, and then we're going to raise that to the x power, which is going to be our time. So we'll plug in 5 for years. Then we grab our calculator and we type it in exactly how we wrote it with the parentheses and everything. And we get back 39,320.8. Because we're talking people, I'm just going to say, I'm going to round to the nearest person, so 321. So what will the population be in 5 years? 39,321 people. All right, how many years will it take for this population to get above 50,000? Explain how you found your answer. All right, so what I would do to figure this out is I would use the graphing calculator to help out. I know that if I type in our function into the y1, so y1 equals, it's the top left button on your calculator. When you click on that, it'll say y1 equals, and then you can type in whatever you want. So we're going to type in our function. Again, we can type it in exactly as we see it. 36,500, too many zeros, there we go, times 1 plus 0.015 to the power of x. And then what I want to do is, I don't want to graph it, but if we hit second and then graph, what we can do is that's going to give us a table of values. And I can use a table of values to help answer this question. All right, so we'll see how clearly we can see this. So here is what I did was I typed the function into the y1, or the y equals, I guess is what it looks like on your calculator, y equals. Then in y1, I typed in the function, I hit second graph, and I want to look at a table of values. So what we see here are all of the years over here on the left, those are our x values, and the y values is the population for each year. So after 16 years, the population is 46,318. So the question we're being asked is, after how many years will the population get above 50,000? So we're just kind of tracking the population, 49, 49, 50. So in 21 years, our population is at 49,898, so it's not above 50,000 yet. But in 22 years, our population jumps above 50,000. So that 22 years, that is what we're looking for. Right, we'll just set that table off on the side. See if it'll stay over there. Okay. So How many years will it take for the population to get above 50,000? 22 years. Explain how you found your answer. So you could write out in words how you looked at the table of values on your calculator and you looked for the year that had a population above 50,000. All right, moving on. Number 6. So number 6 says you received $150 for your 15th birthday. Congratulations. And you decided to invest it. You took what you learned in algebra class, good for you, and found an investment that offered 3.5% interest compounding monthly. All right, so a problem like this, please, 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 will you circle compounding monthly? So compounding, what that means is to calculate interest. So if you're compounding monthly, you're calculating interest every single month, okay? So this is a money problem. This is finance. We have an equation for compound interest. So when you see compounding, we got to use our compound interest formula. The compound interest formula is A equals P is our principal. That is our starting amount. It's our initial deposit or investment. In this case, it's going to be that 150. And then times 1 plus. R is our interest rate as a decimal. So that's that 3.5%. Divided by N. N is the number of compounds per year. So if we're compounding monthly, that will be 12 times in a year. This gets raised to the n times t power. So there's that n again, number of compounds, and t is our time. And the question was, how much money will our investment be worth in 20 years? All right, so we are going to set this formula up. A equals our principal, which is initial amount, $150, times 1 plus the interest rate as a decimal is 0.035 over n is our number of compounds in a year, which we said would be 12, raised to the n times t, so 12 times 20 years. Then we grab our calculator and we type that in. All right, so after we type that in, we get a total amount of $301.76 when we do our proper rounding. All right, so, I guess it took a long time, 20 years, to get that up to $301, but that's okay. So the next question is, how much money did you earn in interest over the years? So what we did is we put in $150. By we, I mean you. You did this. This is your investment. Any amount above $150 at any point in time is the amount of money that you're earning in interest. It's like free money. You just say, here's $150. You guys watch it for a while. I'll come back and check on it. We come back 20 years later, and all of a sudden, it's at $301.76. So all that money above what we put in is interest. So to figure out what that amount would be, we just take the total, 301.76, and we'll subtract out the $150 that we put in originally. And the interest that was earned over the years was $151.76. And I'm just going to write a note in interest. All right. Number 7, a car is purchased for $20,000 and depreciates at a rate of 10% per year. So depreciates, circle it. That means it is losing value. So write the function that will model the situation. So this is an exponent. So we are decreasing by a percent. So that's an exponential situation. It's exponential decay because the numbers will be getting smaller. It's depreciating, it's decreasing. So our decay model, f of x equals a is the initial amount times 1 minus r, subtracting because it's going down, raised to the x power. All right, so for this situation, we'll have f of x equals a is the initial amount, so this is a $20,000 car, times 1 minus r is 10%, but we need to write that as a decimal, so 0.10 raised to the power of x. So I would take that answer, or you could simplify it. F of x equals 20,000 times 1 minus 0.1 is a 0.9 raised to the power of x. So both of those are acceptable. All right, compare the average rate of change. Please, please, please circle rate of change. And what word are we going to write in when we see that? Slope. So compare the average rate of change, or the slope, in the value of the car for years 1 to 4 with the average rate of change and the value of the car for years 5 to 8. All right, so years 1 to 4, those are x values. In our function, x is our number of years. So we've got from 1 year to 4 years. We need to get these ordered pairs for this function. You can do this two ways. You can plug in a 1 and a 4 for the x, or you can go to a graphing calculator and type in your function. When you do that, then you just go to the table of values and you can scroll through and find those ordered pairs. So when x is a 1, y is an 18,000. And when x is 4, we have 13,122. All right, I'm also going to go ahead and get the ordered pairs for the other interval, the years from 5 to 8. So when we have 5 years and 8 years. So when we have 5 years, the value of the car is 11,810. Again, you can plug a 5 into the x of your function, or just look at a table of values. That's what I'm doing. I've got my calculator in my hand, and I'm just going through the table of values, pulling out these amounts that we need. All right, so after 8 years, we'll have the value will be 8,609.3. All right, so we are going to find the rate of change, or the slope, of each of these and then compare them. So slope is your change in your y's, so y2 minus y1 over the change in your x's, x2 minus x1. All right, 13,122 minus 18,000 is a negative 4,878. Divided by 4 minus 1 is 3. So we'll go ahead and divide that out, and we get a negative 1,626. All right, now let's find the slope between these 2 points. So we will subtract our y's. 8,609.3 minus 11,810 over 8 minus 5. So that's going to give us, let's see, 8,609.3 minus 11,810. Negative 3,200.7 over 3. We get negative 1,066.9. All right, so those are the two rates of change over the different intervals. So a common question we get for something like this is this first one decreasing more quickly, less quickly, or at the same rate as this one. So what we do is we ignore the negatives for a minute. This is 1626, this is 1066. This is bigger, which means there's more change happening here. Um, so this is going to change more quickly. All right. Number 8, is the following sequence geometric? Explain. If it is, write an explicit and recursive rule for the sequence. So geometric, what we do is we divide this term divided by the term before, this divided by this divided by this. That's how we check to see if it's geometric. So 243 divided by 729. 81 divided by 243. 27 divided by 81. And we just check those and see if we get the same number. If we get the same number, that is your common ratio. And when we divide that, we get a 1/3 for each of them. So that means that our common ratio is 1/3. This is geometric. In order to write any rules for these, we want our common ratio identified and the first term. So the first term is 729. All right, so the explicit formula, here's what the form looks like. AN equals A1 times R to the n minus 1 power. So really, all we're doing is substituting in A1 is 729 times R is 1/3 to the n minus 1 power. That's all we can do. The recursive formula is AN equals your ratio times A. This has a subscript of n minus 1 that stands for the previous term, and then with A1 equals, we have to identify the first term. All right, so our recursive rule, AN equals, our common ratio was 1/3 times this A with a subscript of n minus 1 never changes. What does change is the first term and the common ratio. So we have to give everybody the first term to start this one out. So with A1 equal to 729. All right, last question. Describe the transformations of f of x equals 2 to the x for the following functions. All right, so if I look at g of x equals 2 to the x minus 4 plus 3, so what changes did we make? We subtracted we subtracted 4 from the x. Any change we make to the x is going to be a horizontal change, and this is going to be our tricky x. It says x minus 4, so we're going to go in the opposite direction. We're going to go right 4 units. All right, we also are adding a 3 to the end of the entire function. Anytime you add or subtract numbers on the end like that, that's going to be a vertical shifting moving up and down. That plus 3 is, there's nothing tricky about that, so it's going to go up 3 units because it was positive. All right, h of x. I can see that we're changing the x's, x plus 1. Tricky x, we're going to go in the opposite direction. So go left 1 unit. And then we're subtracting 5 on the end. That's your vertical change. Because it's minus 5, we're going to go down 5 units. All right, I hope that helped and you guys are feeling more prepared for retaking this test.